let's get back into the 00 conversion.
And we can talk briefly about hide glue. You know, it's got a good track record. It's been used for making furniture for several thousand years at this point, so it's kind of tried and true. It's basically Jell-O, desiccated collagen from animal hides. To prepare it, we take these granules and soak them in cold water to rehydrate them. I don't need it in huge quantities, so I make little tiny batches. I mix it by weight rather than volume because the size of the particles can vary. And for my purposes, I take 30 grams of the glue, add about 25 grams of cold water to it, let that sit for several hours, and then we need to cook it. There are various ways of heating it. Dry heat glue pots are kind of neat. They're very nostalgic looking. But again, I'm not sitting here using it all day like I was in a factory. So the method I used was shown to me by Grant Tomlinson, who's a lute builder. I put the jar in a pot of water, gently heat it up. In culinary terms, it's not even technically a double boiler. It's more like a bain-marie. Just provides a bit of a buffer so the glass doesn't break. The temperature, we want somewhere between 140 and 150 degrees Fahrenheit, which is 60 to 65 Celsius. You don't want to get it too hot for too long, basically, or you'll end up weakening the glue. It's not that much of an issue, really. This is my bridge plate. It's a very old piece of maple. It's got a caul double-stuck tape to it, which will help spread out the go bar clamping pressure. Main thing with hide glue is you want a lot of it on there and you want to work fast. You can extend the working time a little bit by using a hair dryer or a heat gun, but really the main thing is you got about maybe 30 seconds to get things positioned before it starts to gel up. So I'll find the place to put it. It helps if you can sort of slide it back and forth and you can start to feel it grip like that. I'll hold it in position. I can start getting my go bars on. Go bars are just, in my case, a flexible fiberglass rod. Go bars are nice for this kind of work because they are very fast. Like if I wanted to clamp this up using traditional, say, F-clamps or something, it takes too much time. Like this glue is already starting to set up a little bit. I could feel it start to gel. So I'll come along in about 10 minutes and the squeeze out is going to be at a consistency I can basically just roll it off with my finger and then clean it up with a little bit of water on a rag if necessary. It's been several minutes and things are jelly-like. And just sort of rub it off, the excess. People ask, does hide glue smell bad? No, not really. Unless it's old. Like if you were to make up a bunch and sort of leave it around the shop for 3 weeks and then start cooking it up, yeah. Because it's basically a meat product, right? But, you know, if you're using fresh glue, it's not a smell you'd go out of your way to experience, but it doesn't smell bad. It's not a strong smell.
I'm cutting the lap joint for the X-brace. This has to be fairly precise. You want the two pieces to fit very firmly together so they're less likely to open up over time and cause, deforming of the top or buzzing sounds. Makers have been playing with the dimensions and the splay or the angle of the X-brace for years. I just went with the traditional style.
I'll be gluing in the finger braces, which support the edges of the soundboard, and the tone bars, which stabilize the top behind the bridge. One thing about these old Martins is they took the time to cut little pockets for the ends of these braces to tuck into the sides of the X-brace. Almost no one does this anymore. It's really debatable if it was ever necessary. The other thing is the ends of the bridge plate are also housed in the X-brace that way, and it's really a bit of a pain to cut those pockets. The thing is, every other repair person in the audience right now is exhaling through their teeth, making that angry sound, because we know what it's like to try and remove one of these that has been installed in this way, or if we haven't done it before, we can imagine. If it happens to me, if I encounter a pad that's been split through from one side to the other and it's no good, it's got to be replaced, I'll just flush cut with a little flush cutting saw along the edges of those braces and just leave those little pieces in situ, because ain't nobody got time for that, and it's probably stronger if you just leave them in. And these days people are pretty serious about leaving old bridge plates in place unless it's absolutely necessary. Sometimes the soundboard is completely it's messed up in a way, it's turned into a roller coaster and they have to be removed to flatten them out. But things like worn out bridge pin holes, these days we repair them rather than replacing the whole pad. And to be honest, having the bridge plate just butt up against the sides of the braces seems every bit as secure. I can't ever remember seeing one where the ends have come loose. Got a little brass plane that I use on the sides of the braces to round them over, but much of the shaping work is actually done with a big wide chisel. How about tap tuning? Trying to make the soundboard or portions of it ring at a certain pitch or a note or a number of hertz. That's not something you're going to see in most guitar factories. The one exception being Bourgeois guitars. Dana Bourgeois has this regimen for tap tuning. It's really more prevalent in the violin world, and violins are a little bit different than flat top acoustics. Not to say that there aren't individual luthiers, builders of note, who have their own theories about tap tuning, but in a production situation like these would have been, not something that would be in effect. They were looking for certain parameters, but I don't believe notes were part of those parameters. Of course, when selecting soundboard materials, I will tap on them to see what the harmonic content of the wood is like. Is it loud and clear? Is it kind of muted and dull? If it's got a crack in the wood, sometimes there'll be an audible buzz, which would be something to stay away from. I mean, there are places where you can hold the wood that are nodal points, where different lengths of the soundboard, there is not a vibrating area. So you find one of those, and you can elicit a tap tone from it. Very much depends on where you hold it. If you're really into collecting data, you can use an audio spectrometer app on your phone to, sort of check out the resonant frequencies by tapping over various braces. I use a little rubber ball mallet here. D sharp, F sharp on the treble side, D sharp on the bass side. I don't want the soundboard to ring perfectly in tune with a musical note. It gets incredibly complicated, this system that we're dealing with here, because the soundboard alone, removed from the guitar box, doesn't behave the way it will later. But if the finished guitar has a natural air frequency resonance of the chamber, or a tap tone that corresponds with a frequently encountered musical note, that can cause it to jump right out of the mix. It becomes overpowering, as it were, every time you play that note. It'll emphasize it. Like if the box's air frequency is right on G, you're asking for trouble. So basically, I want it to sound lively and musical, and the top should be stiff, but not unyielding. Most of my building experiences come from classical guitars, so I have some breadth of knowledge there from experience. Every single steel string I've built has been different from the one previous to it. So it's not like I've got this huge body of knowledge. because I'm not working with one single model. But I know what I want it to feel like based on other guitars I've handled. You know, there's a kind of resistance that happens where it kind of pushes back against my thumbs in a very reassuring way. It doesn't wobble and go up and down. It's like a single kind of rebound. A good set of shocks in your car. You know, if you carve the braces into something that looks like an original Martin plan, you're probably not going to end up with a bad sounding guitar. You know, it's fairly forgiving. So adjusting the flexibility happens by removing material from the sides of the braces. Removing mass here and a small amount of stiffness, and that increment is small enough that I can do 3 or 4 passes, check it out and see what's happened. It's controllable. Okay, scalloping. It's the magic where the tone lies. It's really just removing excess mass in a very efficient way. And the scallop shape, I'm not sure if it actually correlates with any kind of magic or not. I mean, there are lots of excellent guitars made without scalloped braces. They can be simply tapered. Some braces are just straight. It's all about what it's doing to the soundboard rather than what the brace looks like. Once I've got things flexing the way I want it, I can come back with some 150 grit sandpaper and just blend all of these cut surfaces together into something pretty.
I'm applying a square of linen cloth soaked in hide glue to the intersection of the X-brace, because that's what they did. You could also bridge the area with a piece of wood, which is fine, but that's not what they did. I'm trying to keep it real. I put my name on backwards, so it will appear right way round when looked at in a mirror. I need to cut pockets into the lining to house the ends of the braces, so I'm chalking them, which will provide me some guidance. I'll chisel those out. This is something I feel strongly about. There are people who do X-braced conversions to old ladder-braced guitars, and they don't house the brace ends because it saves time, obviously, but they frequently come loose and it's a pain to repair them. I'll get the outline locked into place by clamping the blocks and waste while they're still in the mold. Then I'll glue the rest 1 inch at a time by putting the glue in the joint and using my spool clamps. Before using a router to trim off the overhang, I'll lay a piece of tape all the way around the circumference. The guide bearing on a flush trim bit isn't supposed to spin, but sometimes there's enough friction that it will, and that can cause some burn marks or little incisions along the edge of the outline of the body there. Having glued up a whole bunch of veneer lines to make some purfling, I have to resize all of those to make them uniform and of the correct thickness.
Well, it's time for the new toy. I bought this a couple of years ago, but I haven't had the chance to really get into it, and it feels like the right time. This is the ultimate binding jig from a company called Elevate Lutherie, not a sponsor. It is a highly refined take on a jig that's been around in commercial guitar building shops for several decades at this point. I'm not sure who came up with it first, but I think it's an iteration of a concept Charles Fox started promoting in the 70s and early 80s in his guitar building course.
The problem with a flat router base and a bearing-guided bit on a curved surface or radius, you often end up with a channel that's irregular in size and tipped outwards relative to the sides.
Anyway, Charles Fox reckoned that by reducing the point of contact with the plate, you could minimize the angle of tippage. So he came up with a design that was handheld. It works fine. But at some point someone realized that by mounting the router sideways and bringing the guitar body to the work, rather than the other way around, you could reduce the point of contact even further, guiding primarily off the sides, and you would end up with a more precise channel. It's also more difficult to tip the body in such a way that you would mess up the cut, which happens sometimes when you're hand holding these things. It takes a little bit of finesse and some experience to make this work consistently. And if I ever get the chance to actually build guitars again, maybe when I'm retired, 77, 78 years old, this would streamline that process a bit, so it's justifiable, right? So looking at the binding channel on the back, the depth varies a lot, from about 3 millimeters to almost 5 millimeters. It's reasonably consistent when looked at from face on, so I'm not sure how they cut those channels. I don't know what that machine looked like. I've never seen it.
After a couple of practice cuts, I was all set to go around the body, and did it a number of light passes. It was all very controllable, not too scary. And the results were excellent. Nice, crisp, clean purfling and binding cuts. I like to hold my binding in place with tape, so I'll apply a light coat of shellac in the area where that will contact the soundboard and help prevent fibers from being pulled up when I remove it. Now I actually had to go through the entire binding process twice, because I started off using canopy glue, which is a model maker's material, and I've had good success with it, doing some rebinding jobs in the last year with celluloid binding. However, in this case, the black binding was ABS plastic, and it did not behave the same way. I roughed up the gluing surfaces like I usually do, but when it had dried, it came loose and peeled right off when I was trying to level it. So I had to go back and reroute, and for the second attempt I used gel superglue. That did the trick. I have no problems with it.
We're going to do something anachronistic. Heaven forbid. As far as I know, all 1934 00s would have ebony bridges. Later on, of course, Style 18 would have rosewood, but not in the early 30s. The owner, however, has found this chunk of Brazilian, and it's got, look at this thing, it's got curl in it. It's really kind of remarkable. So, yeah, I think we're going to bend the rules a little. The amazing thing is, of course, that I can cut this thing pretty close to quarter sawn, which is something I would want for Brazilian bridge. When talking about Martin belly bridges through the years, there are a few things to look out for. This is a modern example. Came off a guitar that's probably 15 years old. There's this curved portion in the belly of the bridge here, where it's a radius. On the modern examples, that radius, there's a flat portion behind the pinholes, and it's about 1/4 of an inch, just over 6 millimeters long. On the earlier ones from the 1930s, that curve progresses much closer to the back edge of the pinholes. It's practically at the end of the countersink here. So that's one thing we have to do, is round this over a bit more than we'd find on the modern one. There's also going to be some slight difference in the length of the bridge between the wings, or the cutouts, or the scoopy parts at the ends here. On this modern example with a drop-in saddle, this is about 84 millimeters long. On the 1930s examples, it is closer to 86 millimeters. This jig I have here, I've actually marked for either of those dimensions on here. Martin bridges have remained really, identical in terms of outline for a very long time. They're always 6 inches long, and the actual curves, there's some irregularity in the earlier examples, like they'll be bilaterally not perfectly symmetrical. Like one wing might be a little bit longer than the other. And there's a certain amount of stuff that happens during the hand finishing process that can make them all a little bit different from each other. We could talk about the height of the bridges. This one here is about 5/16 of an inch, which is kind of standard. We'd like to assume that there is one absolute standard, but there wasn't back in the day. I think they had a number of different heights available to use depending on how the neck set on the guitars turned out. They'd pick the one that most matched. I've seen them as tall as 3/8 of an inch and as short as 9/32.
So I'll plane the radius into the back edge of the bridge. Not sure how they did it in a factory. Probably had a shaper jig. Then I'll route the outline. I'll use the disc sander to sand an arch into the top surface of the bridge. Then I'll sand the curvature into the wings using an oscillating spindle sander. To level the binding and purfling, I'll use a steel card scraper. Then I'll use a razor blade as a scraper to dress out any overage in the sides. It wasn't very much, it was just a couple quick passes. I'll also want to scrape and sand a generous radius into the corner of the binding so it won't cut into your forearm or dig into your thigh. I'll prime the edges using a mixture of shellac and lacquer, sort of a padding lacquer. This will make the eventual lacquer coat stick better, hopefully. Sanding bridges for fun and profit. You want to wear a dust mask with this stuff. Brazilian or any of the rosewoods can be quite sensitizing over time. I know a couple of people who've developed allergies to it, which I want to avoid if possible. I'd like to apply a couple of coats of Danish oil to the surface of the bridge to make it nice and glossy, but before I do that, I will apply some plastic packing tape to the gluing surface. I don't want to contaminate that with oil. That could cause future headaches. I'll just wipe the oil on and then wipe off all of the excess. Let it dry for a few hours and apply again. After sanding the body, I'll get into the finish work. I made a little handle that fits in the dovetail mortise, and I've taped off a little in the fretboard area. To keep overspray from going inside, I'll blow up and tie off a balloon. The player would like an aged relic look, so I'm tinting the lacquer for an orangey yellow tone using amber, raw sienna, and Van Dyke brown in varying amounts to produce a tone reminiscent of the ceiling tiles in a 1970s era tavern. This looks super dark, but it's not nearly that saturated when it's sprayed on in a thin coat. It's a bit of an optical illusion. This is my Pache detail gun. I like that it's gravity fed because I can use a relatively small amount of finish. No, these conditions are not ideal. I'd much rather have a dedicated spray room, but that's not going to happen. It's too cold to go outdoors, so I suit up, and I don't do this very often. After the initial tinting coat, I'll come back and scrape off the purfling. I'll also do the lighter areas of the rosette. Then I'll spray on 6 coats of clear.
Happy Face Balloon Boy says hello. It can be fun to measure the accumulated lacquer thickness. And I put this on just as thin as I possibly thought I could get away with, which turns out to be just over 3/1000 of an inch, which is, that's a real bare minimum in terms of level sanding. In this case, I'm not going to wait a huge length of time before doing that sanding either, because I want to encourage the lacquer to shrink back on the guitar into the soft portion or the summer growth lines of the soundboard to give us that striated or washboarding effect you see in really old guitars that have dried out.
I cut out a period-appropriate pickguard from some dark tortoise material. And here I'm routing it to shape using a template, being careful not to cut into my fingers. I'm fond of them. My template doesn't incorporate the sound hole area because the rosette diameter can vary a little from guitar to guitar through the years, and this way I can dial in just the right measurement. I'll check the positioning. I'll scrape a bevel into the edge. Now this pickguard material is stuff I make myself from much thicker stuff, which I have to sand down to get something approximating what Martin was using in the 30s and 40s, thicker than most of what's available today. Now I'm into neck reset territory, and let me tell you, having cut off large portions of the original dovetail to make the angle right, and then recut it This makes it a serious adventure. You have to pay serious attention to keeping the neck center line straight with the bodies, and also the pitch and the yaw. This is a maneuver in 3 axes, different from the average reset. It took about 3 times as long. And as usual, I want to project the line of the frets to a point just above the front edge of the bridge. I grafted mahogany to either side of the tail and set about fitting it. Before I reinstall the neck, it seems prudent to level sand the body and get rid of any orange peel. I'll start the aging process by dulling it down with some Scotch-Brite, some fine Scotch-Brite. This is just going to take off the super new glossy look, knock it back a little bit. And once again, before finally gluing the neck on, I want to reconvince myself that I have in fact got the center line just right. I'll peel the lacquer from underneath the fingerboard extension. This lacquer is still a little on the tender side. It's only been 3 days, so it comes off quite easily. I'll affix the pickguard. Now, I'm gluing it on top of the finish, but I'm using a solvent-based glue that will melt the lacquer slightly, and that's contact adhesive. Around just the outline, I used a little bit of Tight Bond as well, so I don't get that stuff bleeding out onto the area around the pickguard, which, to be honest, might actually make it look more authentic, like a guard that's come off a few times. However, I'm going to try to be neat. Plotting the position for the bridge, and here I'm just making sure that it's going to be perpendicular to the center line. Then I need to remove all the finish from under the bridge. I don't want it sitting on a lip of material, which is something that many modern manufacturers do, which almost ensures that the bridge is going to come loose at some point. I'll drill through the outside pinholes so that I'll have a place to put some positioning bolts. The bridge is glued on. I'll also glue on the fingerboard extension at this point, having already glued the dovetail in place. I've got this little caul which helps me clamp without crushing the braces underneath. Making a new bone nut to replace the wooden one. Martin, of course, made it tricky for everyone by angling the base of the nut to mirror the headstock, rather than having a perpendicular channel for it to sit in, unlike every other maker. With the new nut installed, I have a good firm starting point, so I can calculate my string length and the compensation required. And I'll route the through saddle slot. Half pencil time. Turns out the fingerboard radius on these is not the 16 inches that we expect of Martin. I'll mark out the string spacing on the nut. I'll get those slots started. It's easier when it's off the guitar. The bridge pin holes need reaming. And then countersinking. Working with bar frets is essentially the same as the usual T-shaped wire, assuming they're firmly installed in their slots. That's a whole other procedure. They do need some crowning in this case, as they've been dressed down at least once. And of course, some polishing needs to take place. I made up a saddle, I got the height where I wanted it, and now I'm gluing it in place with a little bit of fish glue. This is an important component in the through saddle system. It needs to be glued in. It also needs to be fit properly in the slot, too. Not too tight, not too loose. That's what keeps it stable and prevents the front of the bridge from cracking off over time.
Okay, the moment of truth. It's all strung up. I'm going to make a separate little section on the relicking and adding some weathering, which I'll upload this weekend, but this is enough for now. A couple of things. You might say to yourself, boy, that guitar is kind of yellow, isn't it? And that's true, but I'm counting on the fact that this soundboard is going to shift in tone towards the browns over the next couple of years. It happens fairly fast. It's the kind of thing you have to anticipate, otherwise they start to look really weird. I also looked at photos of every 1930s Martin I could find online to compare the various colors they've turned, and this is pretty close to average. I'm very happy with the initial sound. It's been strung up for less than a day, and I like it. The lacquer is going to harden over the next month or two. It's going to get itself all situated, and all the parts are going to start to learn how to work together. And so if it sounds good now, it's going to improve over the next little while too, which is exciting. That's a good feeling. So, at the end of the day, is a project like this worth it? I may have said it in the original video, I can't remember, but this kind of conversion is far more challenging and time-consuming operation to operation versus making a guitar from scratch. It really is. It's a real test. It would be an excellent way to build skills, too, for someone who's interested in repair or building. Not every R18 has to turn into a 00, of course. We should keep some of those around to compare and contrast. I'm glad I got the opportunity to do this one. But there are also a lot of sort of broken down Ks and harmonies and other things from the 1930s and 40s that may have cracked tops or just in a bad state that, you know, they could be turned into a really interesting flat top if you got the time and the inclination. So let's hear how it sounds.